Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Anyway, it's a HP Relay Actuator. I thought it looked interesting. It's fairly cheap, that's why I got it. So it's on the back there, it's got a whole bunch of terminals to basically go straight to the relays. And there we go, a whole bunch of relays. I'm surprised it's open frame actually. But there's a voltage setting, 115 volts, so I need to make that 230. 230 volt, there we go. So that's that changed. Big spiral cap in there, 4000 microfarad. Big device down there. There's a HP part number on it, of course. It's probably just a voltage regulator. So the idea is you push those buttons and it activates these relays. It's got a couple of indicators on the front there. It's got GPIB. Let's plug power in and see if it actually does anything. Oh, something's energised. So that's 1, 2, 3, 4, 5, 6. So number 3 indicator light is gone. So all the relays themselves are switching over, but the indicator is gone for number 3. So I think it's just a single pole, normally open, normally closed contacts with the common. So 6 relays, there's 6 sets of 3 positions on there. I suppose I'll have to test it, see what it seems to work alright. That's marked ABC, and I'm guessing that means wiper. On, off, I think that's what those markings mean. So I believe that's the common, on, off. That's what I think it's set up as. So that should be off. Yeah. So I'm guessing that's 1. No, maybe it's 6. That's 6. Okay. So I should be able to check them all that way. Yeah. 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 Yep. So turn them all on. And check the other way. Yep. So, yep, it's all functioning. I should check resistances to be sure rather than just whether it's there or not. Even though I might have contact resistance issues. Saying 1 ohm. 0.5 ohms. This is my lead resistance, is about half an ohm. 0.5 ohms. 0.5 ohms. I might check that first one again. 0.5. 0.5. Yeah, 0.9. Okay. Check the other ones. 0.7. 0.7. 0.5. 0.5. 4. 0.5. Still both in the same hole. Give it a 0.4. So seems that this one here, relay number 6, which is this one right here, might have a slightly higher on resistance. Get 1.2 ohms there. 1.5. 1.5. 2.6. 2.4, yeah. So that relay there needs cleaning. It's like being open frame means I can actually do it. So when it's de-energized, the relays all switch over. That's interesting. And now I'm getting a low resistance. So when there's no power, they're connected up. But when it's turned on, but the switch is turned off, those are connected up. They're kind of backwards what you expect, isn't it? Weird. I wonder if there's a way of programming it. Switch states. Don't know, I'll have to look into that some more. Right, interesting little piece of gear. So look at what I just found on here. We have some Rifa caps. Well, that's no good, is it? They're going to have to go. They're bound to blow up. Maybe I'll just wait for them to blow up. So I was having a quick look at this, trying to determine why this button number 3 doesn't light up. And if I look inside the back here, I'll zoom this camera in so you can have a really close look. What looks different on that button 3? Right, so it's button 1, button 2, button 3. So anything look different there? Something look wrong? Change the lighting on it maybe? Button number 3, it ain't soldered on. The rod's going through it, but there's no solder on it. It's like they must have just forgotten to solder that one. Let's fix that. Gonna need a little bit of flux because it's 40 years old. This thing's older than me. This is 1973. Pretty sure if I solder this, it's gonna fix the problem. Try and make sure it's definitely etched in there nicely, because it's obviously a bit of tarnishing on there because it's, you know, been around for a while. I'll be a bit tarnished too. I've been around 40 years. Now that's soldered, let's plug power in again and see if it works. Power up. Oh look, it works now. All the buttons now light up. So that has been like that ever since it was manufactured. That's a pretty simple fix, wasn't it? So in the back of here you can see you've got some of these Rifa caps, and maybe you can see there's lots of little fatigue cracks in there. See that? So those are going to fail. They're already all cracked, so those will eventually blow. So they're 2,200 picofarad Y-class caps. So I need to find something similar. Now the only thing I've actually got, which is a Y-class cap, are these. So these are 250 volt rated, but these are 3,300 picofarad instead. So slightly higher capacitance. It shouldn't matter, I mean, it's only filtering anyway on the AC line. So I'll just chuck those in, replace these with these things, and that should do the job. It's going better than what's in there, certainly. Right, let's get this out. Now because these are wrapped around and soldered, I'm just going to cut the legs off and I'll just solder the new ones in over the top. Okay, so have a close look at one of these. So here you go, that's what it looks like on the side. Look at those markings there, 250 volt. It's got the same rating as the ones I'm going to put in. And there you go, there's the Rifa logo. But yep, it's a Rifa cap. That's got to go. You can see all the cracks in it. You can see it's actually bulging slightly. So they're going to blow up soon. Okay, so I'm just going to stick the caps on here. I'm still going to wrap them around so they shouldn't fall off in case something goes horribly wrong. So I'm still going to wrap it, but I'm going to make sure the markings are facing outwards as well so they're readable. I think I'll get my tweezers for this. I might as well get it started like this. There you go, should do it, one wrap. So I solder that one on, then I'll do the other one. Take a bit of heat to get this working because there's a lot of mess. think that's right. That's that side. I think I'll leave the centre one until I get the other one wrapped around. Solder them both in one go. Right, go with that. That's done. Now I've got to solder the centre one. Actually, I want to turn my extractor on. Right. Now, I kind of want to insulate those terminals so you don't accidentally touch them. There's no way of putting heat shrink over that very easily, so I put a large piece of heat shrink over the whole thing. That's a possibility. I've probably got some that'll go around there somewhere. So I've got some shrink here. I was going to put some of this on as well, just as a secondary precaution. Just in case it punches the heat shrink as well. It might. So it might be okay, it might be too big, it might be okay, I don't know. I guess we'll find out. Let's see if I can get the heat shrink over it. If it'll just go. Yeah, will this shrink down enough? That's the next question. It might be too big. Looks like it's okay. pretty good. Looks to have worked. So that's a bit safer now. It's always a good thing. Yeah, so those caps replaced, all done. I think I can probably call it a completed job now. So make sure you subscribe, click the bell icon, and do the create a post thing, and give us a thumbs up as well if you like the video. And hope to see you next time. Share the video too to your friends. Watch out for these caps.